BLOSK is a high-performance compressor optimized for binary data. It has been designed to transmit data to the processor cache faster than the traditional, non-compressed, direct memory fetch approach via a MEMS-CPY call. A drawback of using the cache for compression or decompression is that it is very limited in size. This is surmounted by combining chunking and blocking. BLOS2 supports full 64-bit datasets structured on a double partitioning schema, which means dividing the datasets into chunks that fit in the last level of the CPU cache, and then subdividing these chunks into blocks that are small enough to fit in the first level caches of modern processors. One of the most important advantages of BLOSK is its ability to use multithreading for reading and decompressing several chunks and even blocks at the same time. Moreover, BLOSK implements a block mask capability that allows to selectively choose what blocks are to be decompressed inside a chunk. Here, you can see the kind of speed that BLOSK can reach for BLOSK LZ, its default codec using synthetic data. And here is the speed for summing up a vector of real data for a variety of codecs that come with BLOS2. Thus, you can see how compressing with BLOSK allows to accelerate real computations if you throw enough cores at the task. With BLOS2, you can create a set of chunks called superchunk. These chunks can be stored contiguously or sparsely. Besides, you can choose to store them either in memory or on disk, so that data can be stored persistently. The contiguous superchunk is made by a single structure, which contains the data chunks, the metadata, and an index to access the data chunks. If the contiguous superchunk is on disk, the index, metadata, and chunks are stored in the same binary file. On its hand, a sparse on disk superchunk is composed of a directory containing the data chunks stored as independent binary files, plus another file storing the chunks index and the metadata. Also, BLOS2 has a rich variety of filters, which can be combined with codecs to achieve interesting compression results. Such filters can be pipelined so that the output of one can be the input for the other. In addition, BLOS2 implements pre-filters that can be used prior to the filter pipeline during compression, and post-filters that can be used after the filter pipeline during the compression. The combination of both could be interesting for supporting, for example, encryption via pre-filters and decryption via post-filters. Finally, BLOS2 implements a plugin system that allows users to register their own codecs or filters and even apply for a BLOSK official registering. When officially registered, user-defined plugins are distributed with the BLOSK library and everyone can install them using BLOS2 wheels and use them freely. Enjoy data with BLOSK!